Hi everyone, my name is Saf Aslam and I'm pleased to be the first one to introduce you to NavigateAbility and the team behind it, which includes myself.
Hi, I'm Hannah.
I'm Sneha.
I'm Melanie.
I'm Kripa.
And I'm Dia.
So the problem which we wanted to tackle are the barriers which individuals with mobility issues face when navigating across campus and the subsequent isolation that can cause them from their non-disabled peers. But what exactly does that actually mean? Well, I've been wanting to come to this school since I was 7 years old, and I used to go to every Sims Day that I could. And whenever we would go on the official Georgia Tech tour, or hosted by the ambassadors, I would always get left behind by the tour guiding group. Usually they'd end up taking a flight of stairs or a narrow sidewalk with a pothole that my wheelchair couldn't get across, and I'd be left behind. Luckily, my elder sister would have always spent the week beforehand planning out all of the wheelchair accessible routes across campus, so she could take me on a tour of Georgia Tech where I could see myself as a part of the institute. When I finally got here in my first semester, I ended up spending my first week running back and forth across campus just trying to figure out how can I get to my classes. Anytime I asked somebody for assistance or reached out to a student for help, they'd either point me in a direction which was completely wheelchair inaccessible, or there'd be an e-scooter, pothole, crack in the middle of the way that prevented me from getting forward. By the end of that first week, I had never felt more unwanted by any institute and questioned if I should have dropped out before I even came. NavigateAbility is here to fix that. So to start, the first thing that we did was analyze the actual compounding issues which turn our campus from hospitable to hostile, categorizing it both into temporary barriers like e-scooter littering, debris and blockages, and construction obstruction, and also the more semi-permanent barriers like damaged sidewalks, fenced-off areas, and narrow pathways.
So, similar to Saf's story, we wanted to hear from students across campus, both with and without mobility impairments. So, we conducted a lot of surveys last semester, and we were able to find out that 94% of students report that mobility impairments do limit student participation on campus. And additionally, 87% of these students want some kind of real-time accessible navigation tool that can help them get to class without running into construction barriers or other dangerous hazards that Saf mentioned. That currently there is no barrier alert or online map that can tell a student when there might be a construction detour or something like that, and you just kind of have to find out on your way to class, and that can make you late. Additionally, Via Mara, our current SGA Infrastructure Committee Chair, mentioned that campus accessibility is one of students' most important, yet currently unaddressed concerns by the Institute.
So our solution is NavigateAbility. NavigateAbility is a Georgia Tech specific navigation tool. The first of its core features is real-time route updates. The barriers that we mentioned in previous slides can often happen unexpectedly. This can make you late to class and also cause very dangerous detours. We do this through crowdsourcing. When multiple people identify the same barrier in the same location, we are able to reroute our user in real time. We have also developed a computer vision algorithm that is able to look through submitted photos and analyze the type of barrier, its intensity, and also a brief description of it. This will be especially important for less trafficked areas of campus, as it requires less submissions for proper data verification. The second is personalized mobility settings. Users are able to go in and identify what type of inclines they're able to handle, or for example, if they would like a stair-free route. The third is campus facility integration. We can work directly with campus infrastructure to identify potholes and sidewalk degradation and get those fixed. The fourth is administrative tools. We can look at semester to semester hotspots and trends of where barriers often pop up on campus. They identified 3 core solutions that they use now for navigation, including Google Maps, Apple Maps, and Waze. However, none of those address all of the user needs that NavigateAbility does, including offline maps, custom routes, user-generated alerts, accessibility features, computer vision classification, and crowdsourced data.
So since our proposal last fall, we've made a lot of progress towards our end goal, and we can just explain our project a little bit more to you. So first, we'll talk about our tech stack. For the back end, we're using Python and JavaScript, and for the front end, we're using CSS and HTML. In terms of storage, we're using Google Cloud and Firebase, and then due to the free tier, those costs are minimal. And then for our computer vision model, we're using PyTorch. So we'll go through a quick demo of our product. Let's start here by saying I want to report an incident. I see something on campus others should know about. I can scroll down and press report incident. And then from there, I can select the type of incident I see. So let's say a sideway crack. I can choose a photo of that image and submit that as well, which for some reason, and then I'll choose my current location, and I'll get the current latitude and longitude of where I am. Or I can submit an address if it's something you saw previously. Then you can work and submit that, and then we can go over to our database, and we can see the location metadata, the timestamp, and then the type of data that was submitted. And then from there we can go back over, and if we reload our page, we can see the new marker that has just popped up. The video is glitching a bit, but you can see with the image being populated there, the type, and then that new marker that's just been created.
We're in exhibition hall, and let's say you want to go to Coke from here. So you can see that it plots the shortest path from A to B and the most accessible one, and it goes around that barrier that we just plotted. You can see all of the walking instructions to get there, and it saves all of our recent searches down below so you can access where you went most recently. And similar to a lot of other apps, we have a profile and settings page where you can personalize your own accessibility needs, and then an about page where you can meet the team, see what users have to say about our application, and view frequently asked questions.
Here's a mock-up of our final mobile interface, and you can also scan the QR code again if you missed it the first time. We start on the home screen, which is also the main map screen where you can see any saved locations you may have, any recent campus-wide notifications, and the floating report button. Let's start with routing to a destination. You can click the search bar, find with any of the locations just as Google Maps would, and you route it the most accessible path. As you can see, the path avoids any of the pothole obstacles indicated by the red dot. And if you go back, let's say you want to report an incident, you can click the floating report button, which is present on every page, making it easy to use. And you're prompted to a page asking you to choose a category. After you do that, you're given the choice of taking a picture or manually entering the information. Let's say you want to take a picture, you can take a picture and then submit it to our model, which will then analyze the severity of the incident and also verify the category that you selected. Or if you choose to manually enter, it allows us to enter questions just to verify. Now, to personalize the entire app experience for all the users, we allow you to choose your mobility level so that certain obstacles are avoided. And you can also view the badges based on our gamification features, based on what's unique.
So this semester, we've had the opportunity to collaborate and partner with a lot of organizations and build a sound outreach strategy. So for our collaborators, starting off with our proposal phase, we were partnered with the president of Able Alliance just to ensure accessibility and inclusivity on campus. And we have a very strong connection with the Student Government Association to not only have expansion and funding, but also get the construction data we need from the contractors to update into our application. In February, we pitched our startup at the Society of Women Engineers competition and placed third, which resulted in us getting a partnership from Verizon and getting invited to their research laboratory and startup facilitator. And then with Accenture, we built a partnership with the Data and AI for Good team last month. And with that team, we've really worked deeply on working at the intersection of technology and social impact, and they've been helping us give guidance on our application. With our sound outreach strategy, obviously social media is a very big part of it. So Instagram and YouTube, you can see a screenshot of how we're doing that below. And then we're also partnered with a lot of registered student organizations on campus, like Able Alliance and a lot of Atlanta community partnerships. Lastly, search engine optimization. Obviously, we want people to be able to find our application, so being able to have that pop up first when they're looking for a service like ours.
Yeah, and so we've got a lot of work done, but there's still a lot that we want to do. So looking forward for the next few months, we'll be focused on our technical updates. Melanie showed you our kind of final mobile app, and we showed you the web app. So we're going to work on migrating that functionality over. We also want to add analysis and feedback tools so that users can tell us what they think. And then using that, we can use that to enhance the user experience through processes like gamification or making it easier to understand the routing process.
So once we've completed migrating to our mobile app, we're going to continue doing testing with our user group and also get more feedback from both our users as well as all of our collaborators that Kirk previously listed. And we'll get iterative updates from their feedback. Lastly, we hope to expand NavigateAbility. We hope to include additional user groups such as micromobility users. We also hope to integrate more campus facilities such as paratransit, infrastructure, and disability services. Finally, we hope to see NavigateAbility being used across more university campuses. We'd like to leave you with the idea that NavigateAbility represents a novel and transformative step towards greater accessibility and inclusion across campus facilities, so that every journey at Georgia Tech is one without limits. Thank you so much.
So I have a quick question actually about how your sidewalk impediments could be, I guess, preserved on your database. I'm a bit confused as to, for example, if there is a pothole and then it becomes repaired, is there ever like a crowdsourcing option that tells you that the pothole is repaired? Because otherwise it could be that there's multiple routes and the fastest route now has a repaired pothole, but no one has actually indicated that this pothole is repaired. Because it's easier to notice that there's a breakage than there is like a repair necessarily.
Yes, absolutely. So once a barrier is reported, users that are nearby will be prompted to either identify if it is still there or if it's been removed. That way our data is still up to date. So yes, it is a crowdsourcing solution as well.
You can see it on Google Maps, for example, if there's an installed vehicle, it'll say like, is this vehicle still here while routing you? Our app would work the same way.
What model did you guys use for determining the severity of the tool or the pothole, whatever you guys have options you guys have on your platform, and why did you choose that specific one?
Yeah, so we used a combination of what we mentioned before, PyTorch. We also worked with like their Google Maps or Google Vision has like an API. So kind of just easing up that process because Google API, like they already have so much data. So obviously it's going to be a lot more accurate, but we're also trying to tweak that so that, because we're looking specifically at like units like potholes, we want to make sure the accuracy for that is like very high. So it's still like in progress, but we're working with PyTorch.
And right now, it's kind of just based on that PyTorch and the API that we're talking about. But in the future, we've already started, but working to train the model based on Georgia Tech specific sandbox.
And also just to step in here and say that the best part is that due to my direct experience with it, it's spoiler alert, whenever we need to actually fact check this data and make sure that the vision model is working as it's supposed to, I can go in, I can make sure that, hey, I know this is going to be accessible, I know it's not going to be accessible because I've been doing this for around 20 years now.
Are you guys going to be releasing both on Apple and Android?
Yeah, so how Flutter works is like it allows us to kind of do both very easily, so yeah, both applications.
Yeah, so let's say like, I'm on my way and I use your app, it's like, all right, all clear, I can go and no issues. And then for some reason, while I'm walking towards class, with my class and whatnot, then there's a delivery truck or whatever. So do I get an alert and a kind of rerouting in real time, or how does it work?
Yeah, we're working on the rerouting functionality, but ideally what would happen is you get that alert, it would reroute you automatically, and you would be able to get to your destination and view as fast as possible.
Yeah, and if the alerts are already put in place, you wouldn't even be put on that route to begin with.
Yeah, but that's, I'm thinking more just like you're already on it and
Yeah,
just suddenly.
yeah. Ideally, it would reroute you.
Yeah, okay.
Thank you again for a really great presentation as well. So just so I'm understanding, is all the data from crowdsourcing, or are you pulling other data from, you said you're gonna talk with like some Georgia Tech, so where's all the data coming from basically? You're not using any real-time cameras to pull things or other cameras, or can you expand on that?
So in terms of the construction, we're working with SGA to get those construction updates. They have a lot of like a database, not a database necessarily, but they have all the constructions from the contractors. So we're working with SGA to get those put onto our map as well.
But then it's just crowdsourcing beyond that.
Yeah, so because a lot of experiences you're gonna see only by walking or experiencing it yourself. So with a large user base, you'll be able to have those implemented in quickly.
So I have a lot of respect for the problem space you guys are working on. I think it's great. But as far as the solution is concerned, I'm not able to understand like how it's different from Google Maps and Apple Maps. And especially like they have billions of users using it. I think most people here use either Google Maps or Apple Maps. Like it will take them maybe one day to implement some change and do what exactly you guys are doing. So like, what's the differentiation and how long can you maintain it?
I'll quickly take a step in here and say, well, I respect your respect. At the same time, trying to say that Google will implement this in one day, I think is very naive. First off, Google hasn't even given you the ability to superscript or subscript it in Google Docs, which you're gonna see how far behind they are. But in reality, first off, we'll be doing this in a very enclosed, specific location. Georgia Tech is very unique in that setting. Secondly, if Google is attempting to implement this, you would have to have that brand new feature rolled out to all of its users all at once. You would have to encourage them to try and actually crowdsource this data, encourage it to unique on such a massive scale that it would be almost infeasible. With us, we're able to do it in a consistent, in controlled setting, and more importantly, again, we have the direct experience and necessary with this problem to ensure that it works properly. If something like this already existed, I would know about it. It doesn't exist, sadly enough, and it's a lot harder to attack than it might seem, even though we made it look so easy because we're that big.
Great. Thank you.